The course Introduction to Nonlinear Dynamics is a course about the subject of chaos theory, what is popularly called chaos theory, or the study of nonlinear systems. In the last few years particularly, especially with the advent of computer graphics and widespread use of computers in all aspects of our daily lives, images like you see on the left are increasingly common. They adorn screensavers in the simplest cases. They are there in calendars. For a while, at least in the early 90s, they were sort of an integral part of many promotional campaigns and so on and so forth. Now, all these images share one thing in common, apart from the fact that they rely on fast and very fine computer graphics. They're also the result of calculations done on nonlinear systems. Why do nonlinear systems produce such figures? What is the importance of such figures insofar as dynamics is concerned? What does this say about various aspects of our daily lives? These have dominated the subject of nonlinear science for the last few decades. This course, it's an introductory course, is designed to introduce students to the basic ideas of dynamical systems. I use the word students somewhat loosely over here. Anybody with high school mathematics, by and large, should be able to appreciate the basic points of what this course is all about. During this course, we will focus on qualitative ideas by and large, and I will try to introduce these ideas using somewhat simple systems, simple mathematics, using largely iterative maps as a model. I will hope that students can explore such dynamics by writing their own programs or their own simulation. And as a background, something like MATLAB should be quite enough. Although if you know how to write programs in Python or Fortran or whichever your language of choice is, that's good, in fact even better. The course is meant for, it's a 4-week course, and in these 4 weeks, the topics that we will cover are indicated over here. We look at dynamical systems, look at ideas of stability, look at phase space and invariant sets, and as examples of dynamical systems, we look at maps and flows and discuss limit cycles. In the second week, I hope to cover simple examples of dynamical systems such as the tent map, the Bernoulli map, the logistic map, and some of these very standard things that have been studied at great length in this subject. We'd also look at symbolic dynamics, the ideas of chaos, how to characterize chaos through invariant measures, through Lyapunov exponents, and so on. And in the final week, we'll cover the idea of strange attractors, fractal geometry, perhaps look at time series analysis, and so on. Now, these lectures will rely largely on standard textbooks, which I'll show you in the next slide. So the topics can be mixed. I mean, they can be a little more or perhaps a little less in some aspects of these during the 4 weeks. Accompanying the lectures will be a set of tutorials, and these tutorials will have multiple choice questions. There'll be problems for you to solve, as well as programs for you to write and explore on your own. As far as possible, I'll try to give you material that can be accessed and sourced on the internet. And hopefully, you should be able to do a fair amount of exploration yourself without having to write programs necessarily. The final exam, which is going to be a proctored exam, We'll have both problems to be solved analytically or numerically, as well as those that will require you to write programs and execute them and give the results of that as the answers. The textbooks that I'm going to be following, by and large, are Stephen Strogat's wonderful book, Nonlinear Dynamics and Chaos, with applications to physics, biology, chemistry, and engineering. This is available in an Indian edition from Levant Press, which is why it should be easy for you to get a copy of it. For the somewhat more mathematical topics, I'll use a book by Holmgren, A First Course in Discrete Dynamical Systems. It's a Springer text, and I understand that there is a new edition of it. And relying on the classic Ed Ott's Chaos in Dynamical Systems from Cambridge. Again, there may be a later edition than the 2002, but these three books will form the core of all the for all the lectures that I'm going to give in these 4 weeks.